Welcome to my studio. Welcome my channel studio. Today I will discuss you about the fourth part of the light, or that is the concave convex mirror applications and some mirror formula, also magnifications and also refractions and so on. After the end of the video, or in the 3 or 4 parts, you will be able to give the answers in which in case of street light what type of mirror we used, what type of lens we used, in case of doctors what they used, what type of lens, what type of mirror they used, in case of hospitals, in the solar cooker, solar panel, what we use and how and why, what is the utility of this, or you can give the answers, and also some numerical problems regarding mirror formula. You can also able to give some numerical problems, linear magnifications, refractions, all these things. Okay, so let's start. Yesterday I have discussed about the concave mirrors and convex mirror and linear plane mirror and their applications. Without touching, how can you distinguish between among the three? Also I have discussed, and it is very easy to give the answers. So some of the applications of concave and convex mirrors. One is the converging mirrors, another is the diverging mirrors. Okay? Concave is the converging. They converge the lights in a particular point. And where is the convex mirror is the diverging, the diverge. Light fell दिया. Oh, that को एक पॉइंट में लाना दिया. Okay, so see, what is the applications of concave and convex mirrors? This is the, suppose this is the concave mirror, this is the convex mirror. In this case, what you see out here, this is the bulb. There is the light rays is going, and it is being reflected. It is also reflected. In case of this is the concave mirrors, this is the bulb. So light is going there. It is reflection. Parallel beams of lights are there. So in case of concave mirror, what is the application? In case of torch, bulb, headlight of vehicles, we can use this. This is it can focus the light in particular direction, and particular light we can focus. We can see clearly. Okay, torch, bulb, headlights, and also it is used in the saving makeup mirror also. Savings makeup mirror. We can see free after the savings. We can see the clear image of the face, and also solar furnace. That is in the solar furnace it is used. So it is being converged and it is being heated, and whatever in a container, whatever may be, it is easily being boiled or warmed. And in case of also hospital, doctors, ENT, eye specialists also use because of the magnified. What is the function of this mirror? It get magnified. মানে বড় করে দেখিয়ে দিচ্ছে যেটা আমরা সুবিধা হচ্ছে দেখা. Okay, it is magnified. Okay, so it is the uses of the concave mirrors. Now what are the uses of convex mirrors? Suppose this is in the street light. How this is the bulb? Light is going there, out here coming. That is the wide range of area we can see easily. Okay, that is in case of rear view mirror in the vehicles we can see wide range. We can see also street lights also we can see in the street light. That is light is being ऐसे यहाँ पर जो बल्ब है एक कन्वेक्स मिरर है, लाइट फैलना है, चार्जिंग फैल गया. Okay, and it's also big shopping stores. Big shopping stores we also use this. In the Taj Mahal, what do you see? A light is fitted in this convex mirror. That's why the wide area of the Taj Mahal you can see clearly. Okay, so these are the uses of concave and convex mirrors. Now let's come. फैलना है, तरना है, उतारना है, सब कुछ करना है. So we have to, what you see in the image and object. In case of mirror, concave or convex, that is spherical mirror, convex or concave. What you see, the image and object. Image and object. So that is the size of the object and size of the image. We have seen in some case it is enlarged, in some case it is diminished, it is real. In some case it is inverted, it is virtual. Okay, all these things we have got. So suppose the distance of the object from the mirror be u, and distance of the image from the object is v, and focal length is f. Then the relation by using we can write the mirror formula, 1 by u plus 1 by v equals to 1 by f. This is the mirror formula. Okay, by using this we can easily find out the focal length and or the image distance or the object distance, and also you can also find out the power of the lens, which can be used in the image diopter. Power P equals to 1 by f. Power of the lens we can easily determine. Okay, so in case of what we see concave mirrors, जो लेफ्ट हैंड साइड में होगा उसका साइन की नेगेटिव होगा, u नेगेटिव होगा, v नेगेटिव होगा, I have already discussed, and राइट साइड में होगा तो पॉजिटिव होगा. In that case you have to use v equals to minus, u equals to minus, f equals to minus out there. Obviously all will be negative, and in the concave mirror, convex mirror, it will be positive. Okay, not in all times. Okay, this is the mirror formula, and I will go some numerical problems after the discussions, total discussions. I will discuss some numerical problems. And next, it is the magnification. That is the linear magnification. What is linear magnification? Linear magnification what? What is known? What is known by the linear magnification? Linear magnification is that it is the ratio. This is the ratio of the height of the image to that the height of the object. It is the ratio of the height of the image to that of the height of the object. At is the ratio, it has no unit. The linear magnification or simple magnification we can denote m, that is the linear magnification m equals to the height of the image h1 and height of the object, the object height is h and height of the image be h1. So h1 by h is equal to linear magnification. Clear? Or minus v by u, we can write it. In some cases, in a spherical mirror, linear magnification, in spherical mirror, linear magnification may be positive magnification, may be negative magnifications. Okay, so what is positive magnifications? When positive magnification will occur? In case of spherical mirror, both object and image are upright, that is erect. Object and image are erect. The image is erect means ki erect object and both are erect, that is the upright with respect to pencil axis, that is image is virtual. Image is virtual in case of positive magnifications. In case of negative magnification in a spherical mirror, object upright. If the object is upright, image will be inverted, that is the downward with respect to pencil axis. Clear? The object upright, image inverted, downward. Okay. So in this case, what is the real image is formed? Negative magnification. Negative magnification means real image. Inverted means real. Okay. Erect means virtual. We know, we have discussed earlier. But in case the linear magnification, what is the linear magnification in plane mirror? Linear magnification in plane mirror be always +1. Why? Because the size of the object, image and size of the image are same. In case of what you see in case of plane mirror, what you see? Distance objects and size objects. Size of the distance from the mirror and distance from the image from the mirror. That is the size of this or distance of this all are equal. So in this case, in linear magnification, in case of plane mirror, always positive 1, +1. In case of concave mirror, it may be positive or may be negative. Kyun? May be positive, may be negative, because it is sometimes the image is real and sometimes image is virtual. In case of real, it is negative. In case of real, it is negative. In case of virtual, it is positive. So in some concave mirror, linear magnification may be positive or negative. In case of convex mirror, most probably it is positive, because in most of the cases in convex mirror the image is virtual image is formed, so it is most probably positive. Clear? The linear magnification, positive magnification, negative magnification in case of concave mirror, in case of convex mirror, in case of plane mirror. Clear? So mirror, that is mirror formula, linear magnification is completed. Next I am coming the refraction and refractive index. Okay, so what is refraction? Previous it was reflection, now it is refraction. F-R-A-C, refraction. So refraction means there are some obstacle, so that light can bounce back. Reflection, light can bounce back. Light's incident and bounce back. But in case of refraction, there is no bouncing back, because light obliquely passes through the medium. That is in air to glass, glass to air, air to water, water to air, and so on. Different medium. In that case, there is interface. Surface means interface. But interface means, that means the light from one medium to enter the second medium. In between first and second medium, there is a surface. That is the interface. Here, this is the interface. This is the interface. This is the glass medium to air medium. It is air medium to glass medium. Light comes out here. This is known as the interface. So in that case, light passes through this to medium, and there is a bending band, and light bends. It is not straight. There is a bending of light. So what is refraction? What is refraction? Refraction is that when light, the bending back of the line, ray of light, obliquely, when it enters from one medium to another medium. This bending back, it is slightly bending back. This is known as the refraction of light. Okay? Refraction of light. In case of refraction of light, what we observe, say out here, this is the air medium, this is the glass medium. Air is coming from the air to glass. This is the interface. This is the interface. So in that case, light passes out here from that surface. This is the original direction of propagation, original direction of refracted ray. But what we see out here, this is the normal. Okay, this is the normal. So PA and AR. AR is the refracted ray. This is actually part of the refraction, but it out here bends towards the normal. Towards the normal. What you see? It bends towards the normal. In the second case, glass to air, revert, air to glass and glass to air. This is the incident ray. This is the refracted ray. This is the original direction of the refracted ray. But it should have to go in this way. But it doesn't out here. What happens? It is away from the normal. Refraction is away from the normal. It is the interface. This is the normal. In case of glass to air to different media, light interface, got and refraction. That is in the oblique medium, the bending. Light has the path of the light has bent. This bending is known as refraction. In this case, away from the normal, it is towards the normal. It is the incident angle. This is the incident angle I. This is also I. This is the refracted angle. This is the refracted angle. This is the refracted angle R. This is R. What is C? In this case, I greater than R. In this case, I less than R. R is greater than I. Here, R is less than I. Okay? So, two things we are observing. So, what do we see? In case of what we see, the law of reflection. So, here also, law of refraction. Law of refraction. What is the law of refraction? Laws of refraction. Same thing in case of light reflection. There are two laws: incident ray, refracted ray, and the normal lie in the same plane, same interface, same plane. First law. And second law. First law is same as the law of reflection. Just difference. That is the incident ray, reflected ray. It is the incident ray, refracted ray. Refracted ray. On that case, reflected ray. This is the difference and nothing else. First law. Second law, a little bit difference. In that case, what was second law? It was angle of incident is angle of reflection. Okay, that is I equals to R. But out here, the Dutch mathematicians and also scientists, the Snells, Willebert Snell, he also established this law. The sine, it is the ratio of I. There is sine of I, sine of angle I, and sine of R, sine I by sine R. The ratio in the case of refraction, the ratio of sine I and sine R equals to constant. This law, the second law, is known as the Snell's law, according to the Dutch mathematicians who has given this law and also proved it. Sin I by sin I equals to constant. This constant is known as mu. This is mu. This constant is known as mu. Sin I by sin R equals to constant. Okay? Mu. It is the constant, that is the ratio of sine of angle I and sine angle R. This is the two law of refraction. Okay? See. Now, in this case, refraction, why refraction? Refraction होच्छे कैनो? क्यों होता है? क्यों होता है refraction? क्यों नॉर्मल से दूर में चला जाता है? क्यों नॉर्मल से निकट में आता है? কেন নরমালের কাছে আসে যায়? কেন নরমাল থেকে দূরে চলে যায়? কেন রিফ্র্যাকশন হয়? why refraction occurs? क्यों होता है? And that is the main cause. What is refractive index? Refractive index is very important term. Refractive index. Okay? What is refractive index? और refraction क्यों होता है? You should have to know. So, refractive index, and it is the refractive index. What is refractive index? Refractive index, that is, it is a absolute refractive index or relative refractive index. Refractive index means absolute refractive index, and another refractive index is the relative refractive index. Refractive index is nothing but that is the ratio of the speed of light in air or vacuum and speed of light in medium. In that medium, the absolute refractive index, it is the ratio of the speed of light in air or in vacuum to that of speed of light in that particular medium. It is absolute refractive index n equals to speed of light in air or vacuum divided by speed of light in the medium. Which medium it enters, it passes in medium. That means speed of light means c, and speed of light the medium, let be refractive index. In that case, the absolute refractive index most probably always greater than 1. Why? Because it is always greater than 1. Why? Because the speed of light is 3 into 10 to the power minus 8, 10 to the power 8 meter per second. So it is always greater than 1. Absolute refractive index always greater than 1. But relative refractive index क्या है? Very important. Relative refractive index. It is denoted as n. And one thing remember, it is ratio. Okay. So it is the speed of light in medium 1, the first medium. So that of the speed of light in medium second. Okay. So it may be less than 1. It is the difference of medium, difference of speed of light in different medium. Okay, so it may be less than 1. Clear? Okay. This is the refractive index, absolute refractive index. Oh. Absolute refractive index or relative refractive index. Refractive index कैसे माप होता है? We can measure the refractive index by what? By refractometer. By refractometer. Refractometer जो है इंस्ट्रूमेंट है, we can easily measure the refractive index. Refractive index उसका साथ refractive index इंक्रीज होगा कि डिक्रीज होगा. Actually, why the light, that is the refraction होता है क्यों? Before that, we have to know that what is the optically medium, optically density, optically denser medium. What is optical medium? Optical medium. What is optical density medium? Optical denser medium, optical density and normal density, the difference. Okay, the optical density directly proportional to refractive index. You must know optical density in medium is directly proportional to the refractive index. That is, optical density means it is the ability to refract light. It is the ability to refract light. लाइट में रिफ्रैक्ट करने के लिए जब मीडियम को डेंसिटी होना जरूरत है. कैसे रिफ्रैक्शन होता है? वो डिपेंड होता है उसका डेंसिटी, ऑप्टिकली डेंसिटी, मीडियम को डेंसिटी कितना है. तो ऑप्टिकल डेंसिटी इज द एबिलिटी टू रिफ्रैक्ट लाइट. लो वैल्यू ऑफ रिफ्रैक्टिव इंडेक्स. क्लियर? Remind it. The low value of refractive index means optically rarer medium. Clear? Low value of refractive index means optically rarer medium. High value of refractive index means optically denser medium. In the optically denser medium or optically rarer medium, in which medium light travel fast? Tell me. Oh, yeah, correct. In optically denser medium, light travels slow. And optically denser medium, light slow. And optically rarer medium, light travels fast. Remind it. Okay? So medium जो denser होगा, light slow होगा. Medium rarer होगा, light fast होगा. Speed of light travels fast. But this is the cause of refraction. So what is the cause of refraction? Because speed of light changes in different medium, optically medium, rarer medium, or denser medium. So speed of light changes. That's why refraction causes. Mudda kota. Clear? The speed of light changes. That's why refraction caused. Refraction is due to the cause of the speed of light changes in different medium. Optically denser medium, and optically rare medium. That is the high value of refractive index and low value of refractive index. Clear? Now, next. So what is see in the medium, the optically denser medium, optically rarer medium, we have learned where the speed of light, that is the refractive index is high, refractive index is low. We call that is optically denser medium, optically rarer medium. And what you see, when light enters through rarer to denser medium, when light enters through rarer to denser medium, light enters rarer to, this is the medium normal, the rarer to denser medium, when light enters, then the bending of light in which direction? Towards the normal. Rarer to denser towards the normal. Is the bending of light towards the normal. We have learned. In the reverse case, when denser to rarer, so light away from the normal. When if it is reverse, denser to rarer, so it will be away from the normal. You have learned it. And this phenomenon is very important and helpful to draw something. And one thing is that very important in case of reflection, what you see, when light falls normally, the reflection, the incident and reflection angle is 0. But what is this out here? In case of refraction in a slab, if a light normally, in that case, what happens? In that case, that is sin I by sin R. What will be the value of incident ray or refracted angle? It will be 0. Because in that case, sin I by sin R equals to, what do you see? N2 by N1. What do you see? The sin R equals to N2 by N1 into sin I. That is the sin R N2 by N1 into sin I. As sin I is 0, that is sin R equals to N2 by N1 sin I minus sin 0. Okay, what do you see out here? The sin R equals to sin 0 because N2 by N1 same. So sin 0 ki 0. So R, that is the R equals to 0. So in that case, I equals to R 0, R equals to 0. So in that case, no angle will form. In case of perpendicular, it will go towards perpendicular. And also, if one case, when a light enters in a, suppose air to glass in this medium, what you see, there is a, this is the normal, it will be or away from the normal or towards the normal, but in some case it is no bending, steadfast. When it will happen? When? No change. When? No bending of light occurs in some case. When same absolute refractive index. When same absolute refractive index, so there is no bending. Okay, clear. Now come to the refraction through a glass slab. Refraction through glass slab. It is very important in the lab, physics lab, and it is experimentally proved. Suppose this is air and glass, a light enter is the normal, so it is denser to rarer to denser towards the normal is coming out here. Then again refraction take place. This is the normal. It is glass to air, denser to rarer, away from the normal. So this is the incident ray and this is the emergent ray. This is the emergent ray. This is emergent ray. Emergent ray. What you see, actual propagation of the light is this incident ray. This is the actual path. But it has gone in this way. This is the lateral shift. This is the shift. And what you see out here, this incident ray and refracted ray are parallel to each other. It is parallel to each other. It is the observable, noticeable. In case of Western glass slab, what you see, the incident ray and refracted ray is parallel to each other. And this is known as the lateral shift. lateral shift. Okay, lateral shift is the emergent ray or incident ray. There is a, and they are perpendicular to each other. Or else perpendicular. Okay, perpendicular to each other. This is known as lateral shift. Okay, so I see most of the things is clear. Okay, and go through this 4 video very carefully. No problem. Only one video is I also try to complete in the next one video, and that will be clear. And numerical problem also discuss. So no or no, not on it. If any queries, let me know in my description box. Please subscribe me. Please enthuse me, give energy. Your subscription, one subscriptions, one like makes me energetic and enthusiastic. So I am eagerly waiting for your subscriptions and like. Thank you. Goodbye.